Hello everyone, in this Robot Operating System 2 or ROS2 tutorial, we explain how to create ROS2 publisher and subscriber nodes from scratch in Ubuntu Linux and Python. In particular, we explain number 1, how to create and build ROS2 workspaces. Number 2, how to create and build ROS2 packages. Number 3, how to write Python source files of subscriber and publisher nodes. Number 4, how to incorporate the written subscriber and publisher nodes in the package. And number 5, how to properly source the new workspace and how to run the created subscriber and publisher nodes. By the end of this video tutorial, you will learn how to create this. In this terminal, we have a publisher node that's continuously running. The publisher node is publishing these messages through an appropriate topic. We can see that the message consists of a string and the counter value that's continuously increasing. On the other side, we have a subscriber node. Through the appropriate topic, the subscriber node receives the message and it reproduces the message over here. This is a proof of principle for more complex example. Due to this, it's very important to properly understand these nodes and to learn how to connect them together. Here's the Python script that implements the publisher node. You will learn how to write this script in this video tutorial. And here's a Python script that implements the subscriber node. But before I start with explanations, I need to mention the following. It took me a significant amount of time, energy, and planning to create this completely free video tutorial, as well as more than 450 free video tutorials that you can find on my YouTube channel. And consequently, I kindly ask you to press the like and subscribe buttons. Thanks a lot. Okay, let's start. The first step is to create an empty workspace. To do that, let's start a terminal. And in this terminal window, we need to source our environment. That is, we need to execute this command. This command will actually run this file, setup.bash, and this file will actually properly set up the ROS2 environment such that we can run all the commands. So let's do that. However, let's explain this command in more details. We need to explain the concepts of underlay and overlay. Namely, every time we want to create a ROS2 workspace with packages or run a ROS2 node, we need to set up the ROS2 environment by sourcing the setup script provided by the binary installation of ROS2. That is, we need to execute this file over here. This command will set up the environment and create an underlay environment or underlay workspace, or simply underlay, on top of which we will build our workspace. On the other hand, by creating the workspace with packages in ROS2, we create an overlay on top of the current ROS2 installation. That is, on top of the underlay. So after creating the workspace with packages, we also have to source the setup file for that workspace. And I will explain that later on in this video tutorial. In that way, we create the workspace overlay on top of the ROS2 installation underlay. The next step is to create a workspace folder, and inside of that folder the so-called source folder. So let's do that. We do that by running this command. Usually the packages are placed in the source subfolder. Here, to illustrate the structure of the workspace folder, after the build command is called, we run the build command in an empty workspace folder. Packages will not be built since there are no source file of the package. However, the build command will create several folders in our workspace folder. Later on, after we create an actual package, we will run the build command again. To build the workspace and any possible packages, if the packages actually exist, we type the following. First of all, we need to go to our workspace folder. And in this folder, we need to run this command, call con build. Okay, and let's see what will happen. Okay, summary, 0 packages finished in 0.7 seconds. This command, build, is actually a version of ROS1 command catkin make that's used to build the workspace and all the packages in ROS1. It's very important to know that this command will actually build or create 3 folders inside of our workspace folder. And let's see these folders. Here are the folders: build, install, and log. Let's explain these folders. The build folder is used to store intermediate files. For every package, we will have a folder inside of the build folder. In these subfolders of the build folders, CMake will be executed. Then we have the install folder. The packages will be installed in this folder. There will be a separate folder in the install folder for every package. And finally, we have the log folder. In the log folder, the logging information during the build process is stored. So if during the build process there are some compiling or build errors, they'll be stored over here in the log folder. And you can go over there and you can see all the errors. Next, let's create our first package that will contain subscriber and publisher nodes. First, we need to change the current folder. We need to go to the source folder. Okay, then in this folder, we need to execute this command. Let me expand this window such that you can see the command. ROS2 package create. This is an additional parameter that I will not explain now, and this is the standard thing, ament_python, and the name of the package is first package. Okay, and let's press enter. And you can see that something happened over here. We can see that something is created, some files, some setup files, test files, etc. Perfect. Let's see now the structure of the source folder. Inside of this folder, we have another subfolder called first package. So let's go to that folder and let's see its structure. Here it is. Very interesting. We have several subfolders over here and several files. We will explain these files in the sequence. For us, the most important folder is the folder with the same name as the name of the package. The name of this folder is first package. Let's go to that folder. Now, inside of this folder, we will create a source file for our publisher node. To create such a file, we will need to open a gedit and we need to specify the name of the file. In my case, the name of the file will be publisher.py, since I'm writing a Python source file. And let's press enter to open gedit. Over here, you can also use some other Python editor. If you like to use, for example, Spider, you can use Spider. Okay. The next task is to write the publisher node. Okay, let's start editing this file. As you can see over here, I will write a lot of comments. These comments will help you to better understand this code. The first step is to import the necessary libraries. First of all, we need this library. RCLPY is a Python API for communicating and interfacing with ROS2. For those of you who are not software engineers, API stands for the Application Programming Interface. It's an interface between two programs. Okay, to summarize, this library is used to interface Python with ROS2. This is very important. Now, to our topic, we will be sending strings as messages. Consequently, from this ROS package called std messages, that is standard messages.message, we import string, since we are sending string data structure. Then we need the so-called node class from this package. So we are importing the node class. Here it is. Next, we need to write a class that will govern the behavior of our publisher node. Let's do that. To save our time, here's our class. The name of the class is publisher node, and inside over here I have node. Node that I imported actually node. What does this thing mean? Basically, we created a class that is inherited from this node class, and we do that by using this notation. Again, the publisher node is inherited from the base class rcl_py.node. Keep in mind that. Now, here we need to call the constructor of the parent class or of the base class rcl_py.node, and we specify the name of our class, node publisher. This name will be used later on. Okay, now we need to do a few things. First of all, we need to declare that our node will actually publish string messages. We need to specify the topic name, and we need to specify the buffer size for messages, and we do it over here. We call this function createPublisher from basically base class. We specify the string as a type of a message that will be sent through the topic, and the name of the topic is the communication topic. We can specify the name as we wish of this topic. However, it's very important to use the same name in the subscriber node that we will write later on, and we specify the buffer size. Next, we create a rate for communicating. The communication rate in my case is equal to 1. This means that I'm sending messages every second. You can change this value as you wish. Next, we need to set the timer. The timer will call the function that will be called like this, and it will be defined below. This is a callback function that will perform certain tasks, and it will be called by this timer. So what do we do over here? We set self timer, and then we call this function createTimer from the base class node. We set the communication rate to 1 second, and we specify the name of the callback function. And over here we initialize the counter to 0. This is very important. The next step is to define the callback function. Here's our callback function. The first step is to create the message. We do it like this. Then we fill in the message data with a string. The string is counter value, and we actually specify over here the counter value. The counter starts from 0, and it's incremented at the end of this callback function. Then what happens over here? We are publishing the message. That is, we are sending the message to the appropriate topic. And what do we give as an input? We give as an input our message publisher, and we call this member function publish. At the same time, we will publish the message to the data logger that will display the message in the same window in which the publisher node was started. To do that, we simply call the logger, we specify information. I'm printing publisher node is publishing this string over here, and the string over here is actually the string defined over here. And finally, I increment the counter, and that's it. And finally, we need to create a main function that will serve as an entry point for our node. Here's the main function. Inside of this main function, I'm initializing, then I'm creating the object, node publisher, then I'm calling the function spin. The spin function will spin the node and make sure that the callbacks are called, that is, that this function is properly called. And at the end, I need to call these two functions to properly end my code. And finally, I need to have this part. Okay, so that was our publisher node. Don't forget to save the file and close the editor. Okay, next, we have to edit several files. First of all, we need to go to this folder. That is, we need to go back one step. And First of all, we need to edit this file package.xml. Let's edit that file. Okay, the first step is to edit these three tags. I will simply erase these three tags and I will paste the edits. So over here I'm setting the description of the package, I'm setting my email, my name, and I'm just giving a license. I'm calling a new license. However, here you can specify the license as you wish. After these three tags, we need to add the dependencies tag, and here they are. This is a very important step. Over here, we are saying that our package will depend on this Python library as well as on this one. Okay, don't forget to do this. This is a very important step. Next, we need to create an entry point for our code. How to do that? Well, over here, we actually need to edit another file. So let's go back to this file, save the file, close, and let's edit our setup file. Again, here's the setup file, so let's edit that file. And you need to find this part. And here we need to specify the entry point. So how to specify the entry point? Here's how we do that. I will simply paste the piece of code that I previously wrote. So we need to add this. Okay, so what are we saying over here? We're giving it the name talker, and we're saying the following. First package is the name of the folder for our package. Then the name of the file, the name of the source file is publisher, and inside of the publisher we are calling the function main. This is very important. So again, the name of the folder for the package, publisher is the name of our Python file, and here's the name of the function. This is very important. However, we still have to do a few additional edits. These 4 lines have to be changed, and I will simply paste my edits. So I'm setting the maintainer name, I'm setting my email address, here's the description, I'm setting the license. Note that these 4 entries have to match the entries from the appropriate package.xml file. So everything that's written over here should be equal to everything that you wrote in package.xml. Keep in mind that. Save the file, close the file, and let's create the subscriber node. How to do that? Well, again, we need to go back to our folder. Then inside of this folder, we need to create the subscriber source file, and we need to edit this file. The first part of the subscriber file is the same as the first part of the publisher file, and here it is. First we need to import rcl.py, then we need to import string, and we need to import node. Next we need to define a class that implements the subscriber node. Here it is. Here's our init function. Over here we call the function super, and we specify the name of the subscriber. Over here we are actually saying that this node will be a subscriber node. It will receive string messages. It will subscribe to this topic, and know that the name of this topic is exactly the name that's specified in the publisher node. We set the name of the callback function, and the callback function is defined over here, and we specify the buffer size for receiving messages. And then finally we call again this part over here. This will prevent unused variable warnings. Here's our callback function. It receives the message. Then over here we are simply calling the logger, and we are printing the received message on our computer screen. And this is very important, because if you don't print the message, nothing will happen. Nothing will be printed out. Because what will happen behind the scene, our subscriber node will receive the message, and that's it. Consequently, we need to call the logger to print the message on the computer screen. And finally, we need to add our main function that serves as an entry point. Here it is. Here's our main function. We initialize, we create our subscriber node, then we spin, and over here we make sure that the code is finished properly. And finally, we add this part. And that's it. This is our subscriber node. Save the file and close the editor. Next, we need to add another entry point for our subscriber. So let's do that. First, we need to go to this folder. Then, we need to edit our setup file. And over here, we need to add an extra line that will actually create an entry point for our subscriber. So let's do that. Here's the line that we need to add. And we need to add the line over here. So what I'm saying over here, I'm saying the following. Listener is equal to the name of the folder, the name of the source file that implements our subscriber node, and we are calling the function main. And that's it. Save the file and close the file. And in the final step, we need to build the workspace and run the nodes. However, before building the workspace, it's a good idea to check for missing dependencies. We are using these two packages, rclpy and std messages, and they should come as an integral part of ROS2 installation. However, it is still a good idea to double check for missing dependencies by running these commands. First of all, let's go to the root of our workspace. Okay, and then inside of that folder, let's run this command. And everything looks perfect. All required packages installed successfully. Okay, now we are finally ready to build a workspace in our package. Again, make sure that you're in the proper folder, and let's build our package. To build the package, again, we are calling the command callconbuild. We specify these parameters and we specify the name of the package. And let's hope that everything will work as expected. Okay, now over here you can see this warning message. However, try to ignore this message, because this message will always appear if you try to build a package or a workspace. This is nothing related to the error in our code. This is related to some warning that's related to ROS2 installation. And hopefully in the next version of ROS, they will fix this. And finally, we are ready to run the publisher node. For that purpose, let's open a new terminal. And in the new terminal, let's type source, and let's source this file, setup.bash. Now, notice one big difference between this command and the command that we used at the beginning of this tutorial. Here is the command. So what's the difference? Let's see over here, and let's see this command. Well, the difference is that over here we are actually sourcing this file setup.bash from our workspace. However, at the beginning of this video tutorial, we source this file. So what's the difference? Well, the difference is that over here, by creating our workspace, we actually created an overlay on the top of the underlay. And consequently, we only need to source the setup file from our local workspace. This is very important. Now, let's run our node. To run our node, we need to execute this command. ROS2 run, first package, the name of the package, and the talker. Basically what's happening over here, we are actually running the entry point of the file publisher.py, and that's our main function. And here it is. Perfect. Publisher node is publishing, and we can see the following messages, and we can see that the counter is increasing. And finally, let's run the subscriber node. To run the subscriber node, again, we need to open a new terminal. We need to source this setup file from our local workspace, and let's run our subscriber node. We do it by executing this command, and let's see the output. Perfect. We received counter value 63, and you can see the value, actually the string over here. So publish this part, receive this part. Perfect. Okay, that would be all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot, and see you in the next video tutorial.